Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
28 minutes before 10, and it is time for the Naked Scientist. Chris Smith with us, answering all of your questions. Hi there, Chris.
Morning, Eusebius. How are you?
Great. It's been a long time since we've chatted. Are you off?
Well, a little while.
Let's see what the callers have in store for us today. Let me just invite them in to call. If you've just tuned in, you can, of course, ask your question to the Naked Scientist by dialing 011 883 0702. And in Cape Town, you can call us on 021 446 0567. If you want to send us your questions by SMS, you can do so on 31702, alternatively 31567. One question from one of one of our staff members here have been, why do most animals, Chris, and all human beings have a pink mouth on the inside? I suppose that is as opposed to any other color.
Well, the reason we have the colour skin that we do is because of pigmentation. So if you look at most animals that are hairy, then they actually have the natural colour of skin, which is a pinky colour. And if you want to make skin go darker, you have to add melanin, the brown stuff, to it, which you make either intrinsically because you have dark skin, or you make when you have exposure to UV radiation to protect yourself. So the body has to invest energy in making melanisation of skin. So if there's an area of the body which doesn't see a lot of sun, it's not worth the body's while investing the energy in protecting it from sun that isn't going to shine there. So areas that tend to not get very much risk of sun exposure tend to not have that melanisation, so they tend to be pinker, like animals with fur. And in fact, ancestrally, humans started off, when we had a common ancestor with a sort of ape-like animal about 6 million years ago. The evidence is that our skin was white, and then as we turned into the sort of more modern humanoid that we are today, I say more modern, the humanoids we are today, but our ancestors, as they made that progression, actually had to evolve to be dark-skinned because the human race, as we understand it, evolved in Africa to start with. And then when those humans migrated out of Africa and moved across the rest of the world, when they went to areas where there wasn't very much sun, they had to evolve white skin again. So it's quite interesting. It's gone from being pale skin to dark skin to pale skin, and all the areas that the sun doesn't shine in so much don't get terribly melanised, so they've stayed pink all the way through.
Oh, there you have it. Makes perfect sense. Annie in Lakeside.
Hi, yes. I love your show. Thank you so much for having me on. I just have a question from my 7-year-old who unfortunately can't ask it himself because he's at school. We were discussing the other day about, how water happens to be coming right to your tap and you can open a tap, and I think I rightly said that it's gravity, and, it comes from the reservoirs, and basically trying to simply say gravity pulls it to your tap. He then wanted to know why why gravity doesn't pull the clouds out the sky. And I thought, I'll ask you. And, he asked me to ask you, and I was like, this is a good point.
Morning, Annie.
Great question.
What's his name?
Jude.
Oh, hello, Jude. You can get it off the podcast when we put this out as a podcast later. So, hello, Jude. You're asking a very good question, which is gravity is the thing which pulls masses together. So anything that has mass or weighs something, that actually will be attracted to anything else that has mass. So water up in clouds does weigh something. A big rain cloud weighs hundreds, if not thousands of tons. It's full of water, except the water is in the form of tiny droplets or ice crystals. And because there are winds called updrafts which are pushing upwards, they're actually suspending those droplets in the cloud and holding them up. So as a result, they don't fall straight out of the cloud. And water actually would come straight down if it were to form sufficiently big droplets, and that's what happens when it rains. Basically, water vapour condenses, and water vapour, which is just individual molecules of water, linked together to eventually form droplets of water, and when they become sufficiently heavy they start to fall. As they're falling, then an amount of that water re-evaporates and goes back up into the cloud, so those raindrops may never actually reach the ground. But when they become sufficiently large and the updrafts aren't sufficiently strong, then they they fall out of the cloud, and if the air's already pretty saturated, then they will actually land as rain on the ground, and gravity will be doing the work. So well done, Jude, you're absolutely spot on.
Oh, thank you so
Annie,
much.
will you remember that verbatim or play the podcast?
I did do some notes, but I will actually go for the podcast. Especially for the
Good on you, Annie.
Fabulous.
Thank
Thanks
you
for
very
calling in, Annie. Hi, and you're speaking to CBS and to the Naked Scientist.
Hello, guys. Okay, my question is related to light. Light, is it possible to use light as a medium for sending out information? And if it is, why do we not use light to send it into space, the information, rather than radio waves as we are currently doing now? That's my question. Thank you.
I didn't catch your name, I'm so sorry.
It's Hein.
So it's Hein, H-E-I-N.
Oh, hello, Hein. The answer is, so you're asking why don't we use light to send information out into space rather than radio waves? Actually, light is radio waves. Radio waves, microwaves, radar, X-rays, gamma rays, they're all forms of light, or what are called electromagnetic radiation. So we already are using light, and that's why radio travels at the speed of light, because it is light. And scientists choose the right wavelengths of light, the right frequency, to do the job they want to do. And the new generation of telescopes, for example, are looking at infrared radiation, because it turns out that if we just use telescopes that use visible light, then the visible light gets soaked up by things like dust, and that can obscure our view of distant objects. But looking in the infrared, which is light, which is still light, but it's light we can't see, but telescopes can, it's heat, then you can see lots more detail. Other telescopes look at the X-rays or gamma-ray regime, and things like X-ray bursts or X-ray flashes or gamma-ray bursts when stars detonate themselves at the end of their lives can tell us huge amounts about what those stars were made of. So we are looking and using all these kinds of light, both to look and receive information and also to send out information into space.
Okay, thank you. That's very interesting. Thank you very much.
Cool stuff. Hillary in Savoy. Hello, Hillary.
Hi. Firstly, I have to thank you for your being the highlight of our week. You really are so special, and I have my 96-year-old mother-in-law who just finds you something wonderful and inspiring to listen to.
Wish I could say the same about my mother-in-law, Hillary. But there you are.
And you know what? She's a very special soul, and we're entirely different, but we've got an agreement, and we actually get on extremely well. And she's she's
You'll
a
have to
remarkable
send me
woman.
the secret.
Yeah. Well, I think it's to accept each other's complete differences and respect each other, and that does help, but it's not always easy.
No comment.
What's your question, Hillary?
My question to you, and it's also hers. She said, why is the naked scientist naked? So I would like to know that. Because I can't imagine you stand there and you're all together when you're recording.
Well, the great thing about radio is, Hillary, you'd never know. Would you?
That's true.
And actually, I'll let you know a little secret. It has been known, actually. There have been occasions when I have either had to jump out of the bath or have forgotten that I was supposed to be doing something. Never for 702, of course. It has been known. And I have had to plonk myself down at a microphone in little more than my underpants. But the reason we came up with the name Naked Scientist, it's just over 10 years ago now since we set it all up, was actually, it was the science that was naked. We wanted to sort of take away the barriers and really bring science into the realms of the everyday for everybody. So it was really stripping down science to the bare essentials. That was what we wanted to do. So it's not really me that's naked, thank God, because they also use the phrase perfect face for radio. It's the science that's naked and the subject matter.
Great stuff. Let's take a quick breather. If you've just tuned in, of course, this is one of your favorite features, The Naked Scientist, answering all your questions. And the lines are open, 011 883 0702. That's where you can call in Joburg to place your question. And in Cape Town, your curiosity, you can share with us on 021 446 0567. Leon, Pierre, and many more right after this. 17 minutes before 10, and we are, of course, with The Naked Scientist. One question, Chris, from our SMS line. The story, of course, of teenager Gabby Scanlon, who had to have her stomach removed in that near-death experience this week after drinking a cocktail made with alcohol and liquid nitrogen. And basically, Cindy wants to know, how did the nitrogen actually affect her body?
I was having a bit of speculation about this over lunch, as you do, the other day. because the thing with liquid nitrogen, it is minus 200 degrees C or thereabouts. So it's extremely cold. So if you were to just have it in a glass, it does look like water, but if you were to drink that, your mouth would instantly freeze.
Wow.
So it's very difficult to understand how any liquid nitrogen would get into the stomach in the first place, because one argument that some people have put forward is that the liquid nitrogen got into the girl's stomach, and when a liquid turns from a liquid into a gas, it expands by between 600 and 1,000 times. So if you had, say, a litre of liquid nitrogen, you would make 1,000 times more, in other words, 1,000 litres or a cubic metre of nitrogen gas. And they're arguing that this liquid turns into a gas inside the girl's stomach. It's a closed space, so it sort of blows up the stomach and makes a tear. But this doesn't seem very likely to me that they would actually get physical liquid nitrogen down into someone's stomach like that. It seems a bit unlikely. So we were thinking about other possibilities, and our speculation was that if they made a really strong cocktail with, say, 40 or 50% alcohol, and then they poured in some liquid nitrogen, the liquid nitrogen at that very low temperature would probably freeze the water out of the alcohol, and so you'd have an icy drink, but then with a very strong solution of alcohol. But alcohol remains as a liquid down to a very low temperature. That's why you can use alcohols and things like that as antifreeze. So she could have ended up with a drink that had some water ice in it, but then alcohol, which was at, say, minus 50 or something. And if she were to slug that back, it's possible, because we know that she did drink this thing very fast, that the very cold alcohol would then go straight down her esophagus and into her stomach, and perhaps it then hit the wall of her stomach and sort of froze a small portion of the stomach wall. And when this then thawed out again, it tore. Or when the stomach changed shape, because it's a muscular bag, it's continuously moving, perhaps the frozen bit then just tore, and she got a breach in her stomach that way. But that was the best we could do in terms of speculation.
Yeah.
I don't think anyone knows at the moment. They're still investigating. The bottom line is that this stuff is dangerous, and it's the kind of thing you find in laboratories, not usually in cocktail bars, and you have to be really careful.
And best not experiment. Let's go to Bromfontein. Hi there, Pierre.
Hello. Yeah. My question is related to genetic chimeras. I understand there have been strides that have, that have happened recently. So my question is it possible to have like two different species which are related and create a chimera out of them? Like, for example, a human being and a monkey. Is it possible to fertilize an egg which has genetic material from both the monkey and the human being, and fertilize it and implant it?
What monkey business have you been up to, Pierre?
What are you planning, Pierre? Okay, well, chimeras are something that scientists have used for a little while. And you're right, that when you take two animals that are related, you could take cells and mix them together, and you can end up with an embryo, which is a mixture of the two. And scientists have used this to very good effect in what's called the quail-chick chimera model. And when they were trying to understand how, say, the brain develops, one set of experiments that scientists were able to do was to take the equivalent area of the brain of a chicken and the equivalent area of the brain of a quail and swap the bits of tissue over. And because it's easy to tell the quail tissue from the chicken tissue, you can see what turns into what. And it gives you a clue as to how things wire themselves up and connect together. So tissues which are from animals which are closely related can be put into embryos or developing organisms, and they will follow the normal controls and they will wire themselves up and become part of that organism. And then the immune system can learn that they're part of them, so it doesn't necessarily reject them. So scientists have done basic experiments like that. More recently, they've begun to look at the question of if you take an egg from, say, let's say a rabbit, and you take the genetic material out of the egg, and then you put the genetic material of, let's say, a human into the egg, you've got a rabbit egg, but it's actually got human genetic material in it. What happens to that? And this is actually a very safe thing to do. The difference is you may have some other chemicals there that would only be in rabbit cells, not human cells, but they'd very quickly dilute out under the effect of the genetics. But the answer is that it's an early art doing that, and we don't really know very much about it yet.
Let's go to Durbanville. Hello, Liam. Hello. Okay, let's see whether we can get Liam back in a second. In the meantime, Esme in Verenigen.
Hi, guys. The question is from my 14-year-old daughter. We sat at the dinner table the other night and she was playing around asking me, Mum, why is it that when I blow breath from my mouth as if I want to put it against the mirror and create steam, that the breath would feel warm. But when I blow it with my lips parted, as in wanting to do a whistle or a kiss, the air feels cool. And I don't know how to answer around that.
Hello, Esme. The answer is you can do a very simple experiment. So you can do it with me now, if you like. So if you take your palm and put it in front of your mouth and just with a very wide open mouth breathe onto your palm, what do you feel?
Hot air.
It's hot. Now purse your lips together as though you're going to whistle and blow equivalently hard against your palm.
And it's fairly cold.
And it feels cold. What's the difference between the two? Apart from the temperature. The one with the lips pursed, how fast is the air moving?
I would presume a lot faster.
Yeah, absolutely right. So what's happening when you have your lips close together and you're blowing hard and fast, you are creating a fast stream of moving air which creates a lot of vortices or turbulence, and this pulls in around it lots of other air from the room which is cold, and this impacts on your hand and you feel cooler air. When you breathe out with a wide open mouth, the air which is hitting your hand is principally the air that's come out of your mouth and is the warm, water-saturated hot air from inside your lungs, which hits the hand en bloc, en masse, and therefore feels warm because it hasn't been mixed in with all of the other air from the room, which feels cold. And that's the reason.
All right. Thank you.
Pleasure. Good question.
Leon in Centurion. I wonder whether, by the way, Chris, whether that question was 14-year-old selves. I sometimes think adults are scared to be curious.
No, I agree. We find when we go off and do sort of road shows and that kind of thing, that the kids ask the best questions, but the parents want to know the answers.
Leon, what's your question?
Hi, good morning, guys. Yeah, my question is with regards to the Red Bull Stratos project and Felix Baumgartner's jump. We've been following it really, really closely, my son and I now. He's 13 now. And apparently Sunday is now another window of opportunity where the weather looks, suitable for the jump to take place. Now, here's the question. Felix is going up in a capsule, being pulled up by a helium balloon. Now, does he have to regulate the height to which he's going to go? And the question is, in other words, if he doesn't regulate it, if he just lets it go, will it actually go into the stratosphere and, subsequently into outer space as such? Or will the balloon not go as far as into the stratosphere? In other words, would Felix be setting an unbreakable record for the highest jump?
Yes, very good question. The answer is no, there will be a finite limit to how high it will go. The reason that a balloon floats up in the air is because it is pushing out of the way a volume of air which weighs more than it and the capsule it's pulling up do. And when the balloon takes off at ground level, it's actually not got apparently very much gas in it. It appears to be relatively underfilled, and this is because the pressure of the air at the Earth's surface is relatively high compared with when the balloon is going up to altitude. And as the balloon rises, then it feels less and less air pressure around it, and as a result it appears to expand. The volume of gas gets bigger. And as it goes up and up and up, of course, it's pushing out of the way less and less mass of air because the air is thinner. And so therefore, eventually it will reach a point where the air is so rarefied that the balloon is pushing out of the way or displacing a volume of air which is insufficient to push the balloon any higher, and so therefore it will stabilise at a certain altitude. I don't know if the jump altitude is the theoretical maximum for the balloon or whether they've got some extra potential altitude in there as a safety margin so that if they lose some gas or something else changes, they can go a little bit higher. But no, the balloon would not leave the Earth. It will reach a theoretical maximum height which they'll have planned for.
If you've just tuned in, we are in conversation with the Naked Scientist, taking your questions. The lines are open. Do call in. Let's see if we can squeeze in a couple more. To me in Bryanston.
Yo, what's up, dog?
Good, man. What's your jet-setting question, dog?
I'm good, man. Hey, yo, Naked Scientist, what's up, dog?
I'm good, thanks. You?
Cool. I'm all good. It's all raining up in here in Bryanston. I want to ask you a question. I've been flying a lot.
It's raining here as well.
Yeah, I've been flying, and then I looked at I saw something, like, when you get on a plane, the door is always on the left. And I don't know why. So that's why I'm asking you, because you know everything.
Well, I don't know the answer. Very good question, and I'd never even thought about it. Yes, you always board the plane on the port side, and that may be the reason. It may just be in the same way that boats have a port side, because that was the side that they would approach port on and dock on. And it may be that because aviation and seafaring have common routes and have captains and navigation and that kind of thing, perhaps that's the reason why it's tradition that we get on the left side. And because airports are going to be rigged up to cater for as many different planes as possible, I guess that they think, well, if we put the doors on the left, it will work with everyone's airport. So I think one thing begot the other. Interesting little anecdote. If you watch the film Titanic, if you look carefully at the people who are waving the boat off from the dock when it departs on its voyage, you'll see that everyone's waving with the wrong hand. And this is interesting because if you ask people to wave, the majority of the population being right-handed will wave with their right hand. If you look at the footage carefully, you'll see actually all the people are waving the boat off with their left hands. And you might ask, well, why have all these people suddenly become left-handed in the Titanic films? Did they only hire left-handed extras? And the reason for this is that the Titanic boat was so expensive to build the mock-up of, they only built half of it. They built the starboard side. And of course, when someone pointed out that the boat would have to come in on the port side, they thought, we can solve this by flipping the images round. So they made all of the lifebuoys and everything saying Titanic backwards, so that when they inverted the image, it would be the right way round. But of course, you can't invert the people's handedness, so the people are all waving with the wrong arm.
Good stuff. Thanks for that answer, Dog. Inga in Saxonwold.
Hi, yes, it's actually my daughter Emma's question that I'm going to ask you. We cut her nails every week, and we always have to cut her fingernails, but often her toenails haven't grown enough for us to have to cut them. So she wants to know why her fingernails grow faster than her toenails.
So you say this is for Emma?
Yes.
Hello, Emma.
Emma's not here, she's at school.
I gathered, but she'll be listening to the podcast from the 702 website, won't she, of course. Right. Well, fingernails are keratin. They're the same stuff as hair. And you have at the base of the fingernails special stem cells that grow the keratin. They deposit this protein which forms the nail. And the rate at which those cells are active determines the rate of nail growth. And in the same way that some hairs grow on some bits of the body faster than others, there is no reason why your fingernails and your toenails must grow at the same rate. They grow at roughly the same rate, which is over the course of a year, it's a few centimetres. But there's no physical reason why fingernails, and my daughter calls them feet nails. she's 6. There's no physical reason why they have to grow at the same rate. It will be determined by the metabolic activity of the cells, and that will be an evolved thing. So evolution knows that your fingernails will probably wear out more quickly than your toenails, and this is because we do more things with our fingers, so we're more likely to break our nails off, or if you have a very stressful job, perhaps you chew your nails, whereas you don't tend to chew your feet nails, and you also don't tend to wear them out so quickly, so they probably grow a little bit more slowly. And it comes down to energy. You're saving resources. You don't want to waste energy on growing feet nails that you don't need.
Excellent stuff. Chris, that's all we have time for. Thanks as always for your entertaining wisdom. Have a wonderful weekend.
Have a good one, everybody. See you soon. Bye-bye.